Hello everybody, thanks for attending. So today we're going to be talking about all my command line tools and a little bit extra. So this is basically what we're going to be covering today. We'll throughout touch on Timeline Explorer, but really at the end I'll actually demo it and show you why it's valuable. But the idea is basically that it can open up any of the output from the tools I'll show you today, along with other common output such as Plazo Super Timelines or MacTime timelines or anything that you generate a timeline from a body file. Additionally, it can also open up and dynamically parse any Excel file or any CSV file. So it's basically a means to view any of those kinds of documents using Timeline Explorer. And with the additional functionality such as grouping and nice filtering and everything else, it will increase your capabilities over Excel, I think, unless you're doing some of the things that Excel was really built for, more so than just viewing CSV and drilling down into data like that. So we'll touch on that more toward the end when we get into the demo section. I'll load in some output and we'll kind of bounce through some things and then discuss some of the different functions and features built into that. So the rest of it will basically break down into three categories, which you can see there is evidence of execution tools, document creation and opening, and then other. So that'll be the order that we go in. So as far as how we're going to do this beginning part, I'll talk about what the program is, the basic options, what it would look like to run it, what the output would look like, and then as we work our way through there toward the end, then I'll actually jump back out into PowerShell and we'll run some of these tools and look at the output and continue to unpack some of the features. So one thing I want to make everybody aware of is that these programs don't just come to you as built standalone programs, excuse me. They're not just standalone programs. The underlying parsers are all separate. So if you don't want to use my command line tool, or if you don't want to use a GUI that I've written, you don't have to. You can go to my GitHub page and get the source code for any of the DLLs. And so if you had a means you wanted to integrate AppCompatCache or link parsing or registry or anything else that I've built, the underlying components are there. You can get them, build them, and then pull them into PowerShell, other .NET programs, anything that understands how to use .NET code. So all I've done is taken those parsers and then wrap a front end around them. But you're not tied into using it. And all the functionality and even more is available underneath the hood, so to speak, if you had the need to go in there and build something and extend beyond what I've given you here. So Timeline Explorer will allow you to look at several different things. It primarily will be used for CSV and Excel files. So most tools will output CSV, and then typically the next step you would do is open up Excel or some other Excel-like tool, import the comma-separated value file or tab-separated or whatever you have, and then freeze the column headers, turn on sorting, and all those things. You have to do that over and over and over and over, and then basically you save it out as an Excel file, and then you don't have to do it but once. So what I did for basically during the course of one of my Forensics 508 runs, people either didn't have Excel or it didn't work as well or it was slow to do filtering, so I wrote this. And then over time, as I've taught 508 again and just people giving me feedback, I've continued to add formats that it will automatically understand. So there's really two modes. There's output that I've taken, and you can see some examples there, and then written specific support for those output. So that might be interesting in that if some outputs will have a date in one column and a time in another column, well, that can become a little bit tedious to try and do filtering and things again. So if I natively support it, I can read those two fields and combine them. And then I have a date time, and that makes filtering a lot easier across the board for us after we have that data imported. So that's really the difference. Down at the bottom with the open any Excel or CSV, that's going to give you exactly what it looks like inside the file. It's going to read in the column headers, read in all the data, and then display it in a grid. If there's anything in there that Timeline Explorer identifies as a date and time, it will apply our default date time formatting across the board, and you'll see examples of this as we go through the program output. And then also when I jump out and do a live demo at the end with some of the outputs that I've already generated. So for the command line applications, rather than talk about the same options over and over and over, I wanted to kind of pull those out and then talk about them up front. But keep these things in mind as we go through a lot of the other programs, is that these common features are in most of the programs that we'll be looking at here from the command line perspective. So multiple export options, and so it's pretty straightforward. HTML, CSV, XML, or JSON switches. Whatever one you put, followed by a directory. In that directory, you'll get that type of output, which can be helpful for either a report. Maybe the HTML can be used for a report to pass off to somebody else. CSV, and then to pull into something like Timeline Explorer or Excel. XML or JSON can be used to pass that data off into another system. JSON is especially nice because it's relatively easy to ingest into other systems and then do linking and some other things based on the data that's in some of these artifacts. So there's also options if you wanted to just dump out the JSON and actually be able to read it. It'll put things on different lines and convert the dates to actual strings instead of just numbers and some things to make it a little bit easier to consume. If you're going to be doing a lot of processing and exporting out of data, I recommend that you use the Q option, which stands for quiet. And the idea there is if you're just going to be ripping through a bunch of artifacts and generating something that you're going to look at later, there's no need for you just to watch a bunch of text go by the screen that you're not reading anyway, and that takes time. And so I'll show you examples of with and without and so on, but if you're going to just export a bunch of this stuff out, throw that Q on there and it'll be done in a couple of seconds as opposed to maybe 10 or 15 or who knows, depends on how many files you're processing. So that'll really help speed up what's going on depending on what you're doing. So the other thing that it will allow you to do is I've picked a date-time format that generally works well for everybody and that Excel and by extension Timeline Explorer can import and then do really nice filtering. So it's kind of like a universal format that I've picked. And this has come from feedback from other people in the community. But if you don't like that, you can use the DT switch and put in any format that you want. And I'll show you an example of that here in a minute as well. And then finally, depending on your artifact, you may want to see the higher resolution timestamps, for example, in an NTFS or a file time based timestamp. Typically, you only see the seconds, but if you want to see down to that millionth of a second, there's a switch that will allow you to do that. So I'll show you that as well. So when you run the tools, if you don't know which ones are in there, like I said, most of these are in everything, but just run the tool by itself, no command line arguments at all, and it will dump out all of its options to the screen. And then there's also a bunch of examples and things at the bottom that will make the usage a little bit more clear depending on the tool. But they all look and feel pretty much the same as far as the input options. Is it a file or a directory or where I want to write it to? Once you get the basics down of the 3 or 4 switches that you need, everything else will basically become much, much easier to use. So here's an example of with and without our --MP switch. So you can see there on the left side, we're just calling that all, with the all flag, we see our dates and times. On the right one, we throw the MP on there and you get all the digits of precision after that. So that's really all it's doing. You could mimic that using the next option, the DT, which is this one. So again, same thing, with and without. The one there with, where I have it underlined, that's what you would pass in. So you would put the whole thing in quotes, of course. It strips them out when it displays it. But on the command line, you would just put whatever your format string is in quotes, and you'd be good to go. So all the MP switch does is override the default and put a bunch of that .FFFFF on there, which is your millisecond precision. But you could do whatever you want with these if you had some need to change it up and make it look a certain way. So our first group of tools we'll talk about are our evidence of execution tools. What are artifacts that we can look at that will basically tell us what ran on the system. Now, we're not going to spend a ton of time talking about the nuances of each of these and how they work and all that, but basically we're just talking about the tools because of time constraints here. But I have some links and some things that we'll go into, for example, AmcacheParser, and unpack that in an entire hour webcast, just like we're doing now. So there'll be additional resources throughout, so when you get the slide deck, you can go and you can watch those if something is interesting to you. We will dive into something technical and unpack a certain file format here when we get to the next section, because it's really critical to understand where the stuff's coming from. but we're not going to be able to, just from time constraints, to jump into all the details for everything. So the first one we'll look at is AppCompatCache. So it's pretty straightforward. Down there at the bottom, you can see you have an example. Here we're running it against an extracted system hive. It also allows you, if you don't specify a registry hive, you can dump the AppCompatCache from a running system. So that could be nice. You have to keep in mind that's going to be stuff as it sits in the registry and not necessarily what's in memory that hasn't been committed down. But it's an option if you wanted to just go out there and sweep this. You could go out and pull down all your AppCompat without ripping hives out from everywhere and then running it offline. So very simple to use. You -F is your path to the file, and then in this particular one we're just exporting it to CSV, and in the dot just means the current working directory. So you don't have to tell it what operating systems, you don't have to tell it what control sets. One thing that's different from mine than other parsers is it will go through and look for all control sets that exist in the hive, and then it will export all of them out. And so your output will tell you which control set it came from, because there's plenty of times when both control sets match, control set 1 is equal to control set 2, but I've seen plenty of examples where there's hives where they're different. And so if the program that's doing the parsing is going into the hive and figuring out what the current control set is and only dumping that one, you may be missing an entire other set of artifacts that could help your case out. So you can see here down at the bottom, it's telling us, hey, I found 2. If you want to dump just one, just use the -C option, -C2, -C1, whatever, and you could limit the output. And here it knows it's an XP system. It knows what the data look like in the value. So it just puts that in the output file name so that you have a little bit of context. You would obviously know where you got the hive in most cases, but it just makes your grouping a little bit easier. If you run it against the live system, it will use the host name of the system in the file name. So that way when you're pulling a bunch of stuff back, it's not like, well, I have 10,000 Windows 10 TSV files, now what? It'll tell you the host name in there in the file name itself. When we run this, you can see at the bottom we get the results saved to in our output file. If we pull that into Timeline Explorer, we see something like this. And so I've scrolled down a little bit just to see where the control set 1 and control set 2 breaks. But this is now, you can do whatever you want with this. You can sort, you can group, you can filter, you can hit Control F and find, and it'll do highlighting of the hits for you. We can group by control set. You can tag individual entries using Control T, which then the nice thing about that is then you could filter on the tag which ones are tagged and then export out an Excel file just with things that you've marked as interesting. So it's a way basically to do slicing inside of anything you can pull into Timeline Explorer and then export that out to hand off for somebody else. So you can almost build a mini timeline out of a bigger subset of data across the board. And as we go in there and use it, I'll demonstrate it, of course, and manipulate the columns and do some searching and everything else. All of the controls and the sorting and the column positions, all of that gets saved, and every time you would load back in another AppCompatCache file, it would reapply those. So if you wanted to hide a column, change a position, do syntax highlighting, which this fully supports, you could say, I want you to color anything that has the word unzip.exe in it in purple, and every time it sees that, you'll have a purple line. And we'll see examples of that in our super timeline here toward the end when we look at Timeline Explorer a little bit closer. So that's really it for AppCompatParser. You just run it. It's going to go into the individual hives, pull out all of the individual entries, and then decode them and give us that list. Right? So the thing to keep in mind with, if I go back to this screen real quick, the thing to keep in mind with AppCompatCache is that the date in there, your first inclination and what you want to be true is that that's when it ran, and it's not. It's the last modified time of the file. So you'll catch yourself doing it if you've never looked at these before, and even if you have, like that's the tendency, oh, that's when it ran. No, that's when it was modified based on the date and time on the file system. So keep that in mind. The other thing that I wanted to point out here is you can see there's an executed flag. Depending on your operating system, you may or may not have an executed flag. Some operating systems don't track it. Other operating systems do, and it would tell you true or false. Just because you see something in AppCompatCache does not mean that it ran. So that's a very important thing. And that's where that executed flag comes into play. Now XP doesn't have it, so it just shows NA, but Windows 7 and other systems would show executed true or false, which you could quickly just filter down on, and hey, there's the ones that ran, because it actually keeps track of that stuff. The next one that we'll look at is the AmcacheParser. And so there's a little bit of background here on AmCache, just because it's a pretty big artifact as far as the amount of data that's in there. If I start kind of toward at the bottom, this is one of those links where if you were interested in this topic to really dig into what the Hive looks like, how we do the parsing, how do the tools work, what are the tools testing, and things like that, go watch that hour-long webinar, and it will unpack all those things. So the takeaway here is that it's a registry Hive, so you can use any tool that understands how to parse a registry Hive, but there's a lot of data in there, and how we look at it and how we pull it out, that's where the magic of AmcacheParser is. And that second bullet point there is what that magic is, in that I'm only going to start tracking or exporting out, rather, for you to look at things that are unassociated. So for example, if you install Microsoft Office or Adobe Photoshop and it puts 3,000 files on the computer, you may be interested in those, but I'm more interested from an investigation perspective, at least initially, not across the board 100% of the time, but I'm more interested in things that didn't come from a known good source. For example, did somebody run rar.exe from a temp directory that they either downloaded from the internet or unzipped somewhere and it didn't get there from an installer? So AmcacheParser will filter things out into different buckets. Unassociated means AmcacheParser could not determine what installer put that file there. And then if you use the -I switch, you can also get out all the associated files and then all the program entries, basically everything that was installed. We ran Office, we ran Winamp, we ran Ncase, whatever you installed, those things would be grouped and categorized so that you can filter them out. You could do whitelisting, which is the last point there, based on the SHA, because one of the nice things, artifacts that they added in here, one of the bits of information is the SHA-1. So if you had, for example, a known good image, you could go in there, dump your AmCache, pull out the SHAs of all the binaries that you don't care about, you want to get rid of, right, just because it's less for you to look at, and then those things wouldn't even show up in your output, and it would tell you, I dropped this many because of the whitelist. The opposite of that would be, I found evil, and I have 15 SHA-1s of malware that have run in my environment. Now I want to go out and look for just those. And so it wouldn't show you anything except stuff that matched your blacklist. And so those are the kind of things. I've done blog posts on this as well at my blog, binaryforay.blogspot.com. But that hour-long video will walk you through that as well there down at the bottom. As far as how we run that, very straightforward. You see the same arguments. We see our -F, path to the Hive, and then CSV to the same directory. So it goes through, it processes our Hive, and then down at the bottom you can see we found 16,000 plus entries, total files, and then out of that we're able to call that down and say I only have 243 unassociated entries. So everything else came from an installer. And so I would want to start looking at the unassociated ones, because those are the ones that'll be maybe Windows tools being run, the built-in Windows executables, or other files that got there, portable applications and things along those lines, will make your life a lot easier. Other tools will dump the same information, slightly different presentation, but the other tools will basically dump everything out. So you'll have to go through 16,443 entries as opposed to trying to figure out the 243 that weren't associated. Our output, this is a very small section. If you look at the scroll bar on the bottom, you can see the scroll bar will go pretty far on this, just because this is one of the challenges with forensic artifacts, is that we have this rich data that a lot of times is nested, but how do I represent that horizontally? And so, I mean, the answer is you just keep adding columns, but the downside of that is we have to potentially scroll around. So this comes into why Timeline Explorer is nice, because as you go through these artifacts, you may look at the data and go, I don't really care about this column. I don't want to know just the file name or when it was compiled, or I want to hide 15 of the columns. And so the next time you pull in a AmCache file, those columns will be hidden and your view will be exactly as it was before, along with all of your color coding, any other formatting rules that you've set up, all those things persist and will get reapplied every time you open up one of these files. PE command is prefetch parser. So very straightforward to use, like you'll see, but this one, it goes beyond just a single file, and that we can throw a whole directory at it and then dump out an entire directory full of prefetch in one shot, as opposed to doing them all individually, and then you just export it out into whatever format you're interested in. So you get full support for all the different formats, right? Windows XP to Windows 10. But the one thing to be aware of is if you're going to decompress or deal with Windows 10 prefetch, rather, they're compressed by default. And so I use the Windows API. This is one of the few things. I don't like using the Windows API in general. For forensics, we don't. But I'm not aware of anybody with a known working implementation of this decompression algorithm. Like, there's a few people that are close in it, but I don't know that it's 100% yet. So I rely on the Windows API, which means if you're going to run PE-CMD against Windows 10 prefetch files, you need to be running on Windows 8 or better, because that's where the API exists. If you do that, it'll work fine. If you run it on Windows 7, it'll just say, hey, I can't decompress this. I'm missing the API. So other than that, everything's seamless. You don't need to tell it what operating system or anything like that. It'll figure all that out for you. The one other thing that this does that's pretty cool is, by default, and you could extend this, but it allows for highlighting of keywords. So in the next screen, we'll see an example of some of the output, but most of the time, one of the things that we want to try and key in on is what's running from places that's outside of normal, or what's running from a temp directory, maybe, or the recycle bin, or whatever your investigative interest is. You can set up certain rules around that, maybe certain indicators. Well, PE-CMD comes with two built in. So anytime it sees TEMP or TMP in a path referenced in a directory or a file, it will highlight that line in red. If you wanted to extend that, using my examples a minute ago, to like anything running from the recycle bin or referencing the recycle bin, you can use the -K switch and then add to that list, and it will highlight those entries in red for you. So that can be pretty helpful, just to help your eye key in on certain things, depending on how a lot of data, again, right? We want to use the capabilities of the tools to let us drill down into important things, so that we're not just like, oh, another one. That red's going to jump out at you. So it makes it a little bit easier to identify things, the signal in the noise. So this is a really good one if you're interested in trying, like, exploring some of the internal data. I don't display everything that's in a prefetch file, because there's just a lot of stuff that we're starting to figure out what it's used for. So I don't have it displayed on the output yet. But if you wanted to see it all or push it all into another system, that's where the JSON export comes into play. Because when you export to JSON, you are going to get every single property, every single collection, regardless. It'll often be far more than what you see displayed on the screen. And then for what I talked about earlier with trying to represent that rich hierarchical data horizontally, you'll see a lot more in the JSON. So keep that in mind. That could be very interesting depending on if you're doing research into these things, or you want to pass that off, or and so on and so forth. Those switches are there for that reason as well. This one is also a little bit different, and when you use the CSV export, you don't just get one file, you get two. So you get the normal kind of, hey, here's everything about your prefetch type thing, and then you also get a mini timeline. And so we'll look at that here once we look at what a typical run might look like. So here you see we're just passing in at the top a -F to our prefetch file. If I wanted to run an entire directory, I would use -D, and that's pretty consistent across the tools. So there's our keywords listed toward the top, and then it starts just unpacking things. So you can see the executable name, how big it is. It knows what version it came from, Windows 10. There's our run counts. So here we have 4, but depending on the version of Windows your prefetch file came from, you might have up to 8. And so it would display it just like that, up to 8. Your run counter, of course, would continue to go up. And then it just starts displaying everything out. Here's all the volumes that are referenced. Here's all the directories. And then there toward the bottom is an example of a hit, one of those keyword hits. The string TEMP is in there somewhere. It's on the right side. And so that line gets changed to red. So if we were to put 2017 or bit or anything else via that -K switch, those lines would automatically show up as red as well. This is an example of what our main output looks like. So the primary CSV file is going to have the prefetch file it came from, the source modified, accessed, created, the executable, then you see everything else just kind of running out to the right there, the hash, the size. So we're basically taking that vertical output, moving it horizontal, and you're good to go. Way out to the far right, you'll see a list of all the files and a list of all the directories. If you wanted to unpack those, you can use Control-C throughout and then dump it into text editor or whatever you want and then start browsing through those. But I include them in here, but to try and look through 80, 100 directories this way, trying to put them in their own columns, it's not feasible. So they're in there, you just have to pull those out if you wanted to drill down into something, or if you see something interesting here and you want to go back and reference it, you would just run PECMD against an individual file, and then of course you could scroll up and down or redirect your output and have all those details unpacked for you. This is what our timeline view would look like. So it's very simple. We have a runtime, and then you get a runtime, each one, and then the name of the executable that corresponds to that runtime. So down there, the ones that I have in the red there is atom.exe. So you see the runtimes, and then there's the output from the screen we saw before. So it ran 4 times, so we would expect to see 4 entries, which we do, and then our runtimes correspond. So this is a really nice way just from prefetch to say, give me all the runtimes. You could drop this into other timelines or whatever else you want to do. This was a suggestion that Rob Lee had, and we put it in there. It's pretty straightforward to do, and it's valuable. So you keep that in mind. It'll tell you when you're using the CSV output, you're going to get 2, and this is the second one. So that takes us away from evidence of execution and over to document creation opening. Primarily, we're going to be talking about link files or containers that have link files in them from this point forward. I see a couple of questions coming in. I'll get to those at the end as well. So if you have any questions, feel free to type them in whenever you want, or we'll have a set time at the end. Of course, you're free to pull in any questions, and we'll go through things there. So the first things that we want to talk about, or the next 2 things are going to be LECMD, just straight up link parsing tool, and then JLECMD, which is our dump list parsing tool. But before we get into those tools, I wanted to spend some time talking a little bit more on the technical side, because one thing that I am an advocate of is not just presenting how to use a tool and here's some output. Like, I want people to understand what the data looks like, where it comes from, so that you see something, you see a relative path, you see arguments. Well, how does it get there? How does a shortcut track that? All the nuances of the binary format. So the next few slides, we'll walk through parsing, how to actually rip all this data out of a link file, so that when you run the tool, you're going to be able to reference back to this and go, oh yeah, there it is, there it is. Here's these common structures. They're used here, 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 and here, and I can see patterns not only in other link files, but in other forensic artifacts. You'll see the same types of structures used in a lot of different places, in the registry, in, for example, shell bags, other registry keys. The same things get used over and over. So by starting to understand the underlying data format, you are going to be better prepared to explain what you're looking at and then find those same kinds of patterns in other places. So with that in mind, a link file looks like this. It basically has 2 primary buckets of information. We have our header, and then depending on what's in our header, we've got a bunch of other data sections and then some extra stuff at the end. So some of the common data sections would be the target ID list, what is the name of the shortcut, the path, you could see those there, is it Unicode or ANSI, and then any command line arguments, is there a hotkey, what's the icon, all of those things will be encoded in the binary payload of a link file. So this is what our patient looks like, just X-Ways Forensics. So I just brought up the properties, and that's what it looks like. So the things to look at here, you can see we've got our target, we've got a name, we've got a comment, we've got a run, it's in a normal window, no shortcut key, and it's an administrator, okay? So on the right, that's what the link file looks like in WinHex. So that's what we're dealing with here, is just a big blob of hex. Now you can start picking out certain things in there. like I can see some strings, right? We see X-Ways Forensics.exe, and there's some other things in there, but there's a lot of other details in there, and that's the kind of stuff we'll start working through next. So if we look at the header, this is what it looks like. The yellow part is the header. So it's hex 4C bytes long, and then each individual piece of the header I've put in a different colored box, and then there's an arrow that kind of gives you the description. So the GUID, that's the signature. If you're going to be carving or pulling things out of other artifacts, one thing you can look for is the 4C and then that GUID. And if you see that, that's generally going to be the preamble, so to speak, for what a link file would look like, part of the signature. The next part is the data flags, which we'll spend a minute unpacking that in a minute, but that's going to control what else exists inside of a link file. Okay, so and we'll see a broken down example of all those flags here in a second. File attributes works the same way. This one's 20, so it's an archive. And then there's your dates right there following after that. We have 3 groups of 8 bytes. Those are your created, accessed, modified. So those are 64-bit file times, and they just one after the other. You pull them in. If you took those byte sequences and put them in a decode, you'd get the dates listed down there. Okay. Next section, size, icon index. We already saw that, right? There was 0, there was none. So it's the first icon. If you were to go in, if you've ever done this and change the icon for a shortcut, and it was the 3rd icon, you'd expect to see a 3 there. Okay. Show window information, normal windows, value is 1. There's tons of different ones, and I have references in here for where you can go look at all these flags. But this is basically the rules of how the header determines everything else that's going to follow after this. So at the bottom of this particular slide, I broke down what those values are, just to see how they do line up with, of course, what's on disk, and all the other stuff is going to fall into play based on what we see primarily in that data flag section. So the first thing when you start talking about, well, how do I even parse a link file, is you have to respect what's in the data flags. And so in this particular example, and I just pulled in the data flag section again there, you can see we have 8F200000. So that's little endian. If we flip it around, you get 28F in hex. If we break that down, and obviously there's a list of these flags, it's not like you just, well, I know what those flags are. You go look at the list, you keep track of them, and you break it down. But this is how that one number allows us to keep track of all these individual things, because each number corresponds to a certain payload, if you will. It will give us the fact that we see a 1 there. That means that we have to parse out a target list. We see a 2, link info. 4, it has a name. 8, it has a relative path. Our encoding is Unicode. And so down there at the bottom, that run as user, that's, if you recall from the shortcut, the patient screen, it runs as administrator. Well, the fact that we have 2 there, or 2000 rather, that is going to be what controls that. So if you wanted to make any shortcut, run as an administrator without going in there, properties, this and that, you could just go change that, the necessary byte in the link file and the binary data, and it would work. And for people that have used XWFIM, my X-Ways installer, that's exactly what I'm doing under the hood, is creating a shortcut and then editing the binary properties to turn that functionality on. So down at the bottom, we kind of reverse the process. So we say, well, target ID list is 1, and link info is 2, and has name is 4. And now you can see everything goes up 1, 2, 4, 8, 16. It's going up by powers of 2. That's how when we add all these things together, it can reverse the process and pull out all the individual flags. So if we add things up at the bottom, 1, 2, 4, 8, 15, we get F. And then the next section would be 80 plus F. And so you can see how we build that back to our 208F. And that's what gets stored, and we're good to go. The link down there at the bottom would give you not only these flags, but a list. There's way more than this. But this is just a nice example for how we can take a 32-bit number and then pull all this other data out that controls what actually is going on under the hood when you double-click on a link file or parse them out with any given tool. Okay. If I go back to here, we're going to be going through our data flags now. So you see we have has target list, has link info, name, et cetera, et cetera. That's what we're going to start jumping into each section here now. So following this, because we have the target ID list flag set, we have to parse out a bunch of target IDs. So the salmon color is our target ID list. How do I know that? Well, we read the first 2 bytes, that's the size. and then I can read that many bytes out, and then I have to understand how to process them. But these particular things are shell entries. And so you can see here I've got the 14 is in red. It starts with 1400 1F, 1900 2F, 4A 0031. Those are shell entries. Those are exactly the same way. If you've seen any of my shell bags presentations, that's what we're looking at. So if this particular thing interests you, go out to the YouTube or the SANS website, and you can look for my Plumbing the Depths shell bags talk that I did at the DFIR Summit, and we will unpack how each of those work. So what we're doing, the first step is to figure out what bytes are in our target ID list. Then we cut those bytes up into chunks, and then we process each chunk. And once that's done, we get this. So we now know it's my computer, it's the C drive is next, then we have a directory, then we have the file itself. But look at all the other rich data that's in there, from MFT entry and sequence numbers to created last access to modified, and so on and so forth. So we're able, if you look at the binary here, if I'm going to go back a second, just in the pink, we don't see any dates or times or MFT, just stored. But if we know how to follow the rules, and this is what the rules is one of the things that Shellbag's presentation unpacks, we can start finding these structures all over Windows, especially things like the directory and the file entry. The extension blocks, that beef 004 is everywhere, everywhere. You do a regular expression search for that, and you're going to get thousands of hits all over the place, which is good for us because we understand how to parse it, and we can leverage those forensic artifacts and find new ones that we weren't even aware of before. Okay, so this is what we get when we turn the pink into a nice list that we can understand. And the absolute path there, that is not stored in a link file, but LECMD will build that as a result of iterating down through all the target ID lists, just so that you don't have to do it, right? You don't have to sit there and go, okay, my computer, then C, and it's figure out the directory and then the file. It's going to do all that for you. So it makes it nice. The next section, because the link info flag set looks like this. We have that purple background. We break out in each of the individual pieces. The one thing that's really interesting to look at in this one is that volume info. So why do we like link files? And especially when we leverage them in context with shell bags, is because link files have MFT sequence number and entry number. Shell bags have MFT entry number and sequence number, but shell bags don't have volume information. What's the serial number? And so on and so forth. But because the link file will track a full path, directories and files, we can then match up the MFT information to shell bags to link files, and now I can correlate shell bags back to a known actual device because I can pull the serial number from the link file. This is where it comes from. It's in the link info blob. We'll spend a minute here on the next slide talking about that volume info one. And the other thing, as far as how to read these, the thing you need to be aware of in here is when you see these offsets, and you can see, for example, the one in yellow, that offset is going to be relative to the section that we're working on. So it's not 1C bytes from the beginning. You have to do it from where basically the start of the purple block. So relative offsets versus anything else, versus an absolute or anything else like that. So those are the kind of things that we need to be aware of when we're parsing these things out too, is just the individual context. The developer, when he built this, that's how he decided to do it. So we can go through here. We figured all the individual pieces. You can see we've got that local path in there. So there's an offset to the local path. So if we go in the green, if you go to 2 delta, that's where it starts, and you have your string, okay? So the next thing we want to take a look at, though, because it's important and it's pretty cool to see how this comes out, is that volume info. So I just basically cut those bytes out that was in the blue on the previous slide, and this is how they break down. So we have our size, we have our type, could be fixed, removable, network, whatever. The next one is our serial number. That's where it comes from. Okay, and then the last part is the offset to the drive label. And so you could, this is a good example of relative, right? And this is one of the reasons I did it this way. We pull the bytes out that make up my chunk of data, our volume info. So that relative offset to the drive label says 10. And if we go to offset 10, we see 0. Well, if there was a label on this particular drive, that's where it would start. It would say C drive or stuff or whatever you called it. and then be terminated with null character. But since it's just null, there's no label. And that's basically how you would pull that stuff apart. So there's where your serial number is. And of course you could see little endian comes into play again. But that's where that stuff comes out of. That's where we can extract that information out of a link file, and then, as I mentioned with shellbag stuff, apply it to a wide variety of other forensic uses. The next one will be the name, and we're just basically going right down the link file bytes. We figure out how big it is, we read them, we do something. We go to the next one, we figure out how big it is, we do something. So the next one, because of this flag is set, is our name. So you can see there's the length of the string. But one of the other data flags that was set in our header is the Unicode flag. And because of that, we need to take an account for the length of the string. We basically have to multiply that by 2 because of the way Unicode works. That's how many bytes we would read. Then we can decode it, and we have our value, and there's the name that we saw in our patient screenshot, X-Ways Forensics 32-bit. If the Unicode flag is not set, you just read that number of bytes because it's 1 byte per character. You're good to go. The next section, relative path, works exactly the same way, but there was that flag set, so we have to go in there, read out the relative path, and we get the ... / thing all the way to the path to the binary. Finally, once we get through all of our flag entries, we have the extra blocks. And so basically this is just chunks of data concatenated one after another that you have to look at the signature and then process them accordingly. So for example, here we see 3, the light blue and then the purple and then the yellow. The yellow, the first 4 bytes of the size, and when you see 0 for the size, you stop. There's no more blocks. So we can cut those 2 up, and here's where we would see things like tracker database or property store, things related to the console and so on and so forth. And as an example, we'll look at processing the tracker database. So this is what this looks like. We could have done the same thing with the property store, but let me go back one. The stuff in purple, if you've seen the shellbag stuff, you'll recognize in there a very common pattern. You'll see the 1 SPS. It's kind of split across line 240 or offset 240 and 250 there. 1 SPS, serialized property store. And so that's always awesome to see, because now we can go in there and rip a bunch of good stuff out of there and make use of it, including search results. And I mean, there's just so much good stuff in those. They're used throughout Windows extensively. But this is what our tracker looks like. So here, if you've ever looked at the output from a link parsing tool, you might see things like when it was created, the MAC date, or the MAC address, excuse me, the machine ID, the name, like the name of the machine where the link file was created. This all comes from the tracker database block, and there's where all the bytes are. The majority of the payload is going to be GUIDs, and each of the GUIDs there, the volume droid, file droid, birth, both of those, they're all going to be encoded in there. And then we just convert them. You convert the bytes to the GUID, and then you have them, and then you can extract things like the MAC address and the creation time from the MAC address, because it's a V1 GUID, and you're good to go. You have those timestamps that we can pull out that are embedded in one of the GUIDs itself. The other thing that's cool about LECMD that other tools don't do is we know the MAC address. So I have a list built in with thousands of vendors for MAC addresses, and then I take the first 3 hex chunks, look up the MAC address in my list of vendors, and tell you, oh, that's a Dell, that's an HP, that's a VMware, whatever, whoever made the NIC, just to give you a little bit more context as to where this particular link file came from, right? So you have the machine name, and then you have the NIC, and then a vendor, and those kind of things embedded in there, which on the output, when we look at the output in PowerShell and then the Timeline Explorer CSV stuff here in a minute, we'll see examples of all that too, where it shows us the vendor. Now that we have an understanding of what we're actually talking about when we're dealing with link files, we can actually process one. So LECMD is the tool that we'll use to deal with link parsing. So LECMD has an underlying parser that I've wrapped in a command line tool. The next tool that we look at that relates to jump lists, we'll use the exact same under the cover parser that LECMD is using, right? So we're just reusing functionality, basically removing other layers, kind of like the Russian doll or an onion. We just keep peeling back the layers until we get to something we know, which is going to be link files for the remainder of these 2 topics. So all the available structures are going to come out with LECMD. You're going to get all the target list shell items getting decoded. It's going to look very similar and feel very similar to the information that you'll see come out of Shellbags Explorer. And then there's that Mac vendor lookup thing. If I give you an example of what one looks like, there you go. So there you can see our flags. This is the same file we just did. So there's our flags. There's in a programmatic fashion across all the link files you give it. And you get the results to the screen, or you can use one of the export options. You could redirect this to a file, whatever you want. This is what an example of what the output would look like. And again, you can see that scroll bar at the bottom. There's a significant number of columns to the right where we can go out, and then you can resize and get things set up to make your analysis make the most sense to you, which we'll do here in a minute when we actually start loading stuff in. So link file, basically very straightforward. It's just going to go in there and dump that stuff out. Jump lists. Jump lists. We have custom and we have automatic. Custom destinations, for the most part, is just a concatenated collection of link blobs. So you take that hex and you just keep putting them back to back to back. Now there's some other separators and different groupings and things that can happen in a custom destinations jump list, but for the most part, it's a series of link files, bytes, put together end to end. Automatic destination jump lists, on the other hand, those are basically contained inside of an OLECF container, which is like a mini file system. So you have a directory and a desk list and all these other things that basically will get tracked in the directory. So there's another layer of obfuscation that you have to be aware of. But once you understand how these things are packaged, at the end of the day, in both cases, we're dealing with link files. So everything we just did to walk through that example, it comes into play. And everything that you can look at with LECMD will come into play. JLECMD will also allow you to dump out all of the embedded link files inside of jump list to a directory. So if you wanted to validate a tool or export things out because I like processing I like processing link files in this some other tool, you can use JLECMD, dump out all the link files, and then use whatever tool you want. Down at the bottom, here's another reference out where I unpack what the OLECF container looks like, how it works, and then the custom destination format. So if you want to dive way down into the technical weeds like we did on the link file thing, there's going to be there's a reference down there for you to do that as well. This is us running it. You can see just give it the path to a file. We could also give it a directory. If you pass it a directory, it will figure out if it's a jump list, and then if it is a jump list, which kind. So this particular example is an automatic destination. So we'll see those extra things in there like the number of desk list entries, the version. This was one of the things where Windows 10 broke a lot of tools. So one of the blog posts that I did was the one that I referenced on the previous page. Up until almost a year after Windows 10 came out, jump list tools didn't work against Windows 10 because the format had changed. And so when I started writing this, I was like, why is nothing's working? It's from the rules from Metz's documentation and some other resources. Nothing's processing anything. So once we went in there and figured out, oh, well, they added 2 bytes and this, that, and the other thing, everything else just fell into place. But this is one example of where my philosophy of like if a tool doesn't know how to process something, it should fail spectacularly. It shouldn't silently error, just stop doing stuff or return to this. It should give you like, I blew up, I didn't know what to do, something's wrong, so that you can at least ask, send me a file, go to another tool, something. Okay, so that blog post will have a lot more details on that particular investigation, if you will, and how we figured that out and unpacked it and wrote support for Windows 10 as well. As far as the output goes, like everything else, CSV looks pretty straightforward. We have columns all over the place, and that we can group by application ID, we can sort, we can filter, we can do finds, all kind of different things, which we'll get to here pretty soon. Almost done with the slides, and then it's going to be demo time. So bstrings, this one I'm not going to spend a ton of time talking because I'm going to do a lot of demos on this because the other ones are just me generating CSVs. So rather than actually generate them, watch me generate a bunch of CSVs, I've already done that. I'll load them in the Timeline Explorer so I can demo Timeline Explorer. But bstrings is my strings utility. Stands for better strings. I wrote it when I was taking Forensics 408 a couple of years ago, and then we just kept extending it, right? So people would say, hey, it would be nice if you did this. Well, what about that? And I want a regular expression for this. And this is what we got. So short version of functionality there. When you run it without anything, you get hammered with options just because it can do quite a bit. But this is where we're going to actually start in a second here. I'm going to bounce out and we'll actually start running this. Okay, so I have a list of things that we'll do with bstrings, and then I'll show you Timeline Explorer as well. So with that, let's do a demo. So in this directory here, I just have my tools. So I've got some jump lists, some link files, et cetera, et cetera. I'll bounce out in a minute and load Timeline Explorer, but first we'll do bstrings for here for a second. So I'll just do -F, and then I'm going to do the, let's see, system hive, and then I want to do LR is look for regular expression. So if I type something here, it will be treated as a regular expression. So I could do whatever I want. If you know how to write regular expressions, that's great. But anybody that's ever written a regular expression knows how nasty they can become very quickly when you're trying to do anything other than extremely simple matches. So what I did was build in regular expressions that are commonly used. So if I throw this -P switch on there, let's see what we get. I get things like GWID, phone numbers, UNC paths, social security numbers, credit card numbers, IP addresses, emails, URLs. So now I don't need to worry about complicated regular expressions. All I need to do is type URL 3986 and it will find every single URL that matches that regular expression for me. Now if I go up here, this is the regular expression that you would have had to type at the command line to make it work. So rather than people have to do that over and over and I've got all these great regular expressions, I built them in. So this is one of the examples where you could see everything that looks like follows that RFC will get extracted out of there. And so that becomes very nice very quickly because I can do this against memory. I can do this against individual processes that I've dumped out. Binaries, it doesn't matter. You can do strings against a file that's 5K or that's 5 gig. It doesn't matter. This will handle all of it without any issues. If I do another one and do like an IPv4, there's our regular expression. Let me just zoom up. Here, there's our regular expression there, and it keeps going a little bit. Now you see everything here. We've got matches on our IPv4s. And you can see the other thing with this particular one, especially, you get the syntax highlighting for where your hit happened. Now you can strip off everything except what matched. There's another switch for that. But this becomes nice again because your eye is going to key into those hits as opposed to where's the IP address in this crazy long line. It helps you jump into there and figure out what's what. So that's pretty cool. We can do those things. And it's really quick, right? I mean, I can go in there and just tell it to find me all the strings. And if I just give it either Q or S, it'll go through that hive. And I've found 73,000 strings in just under 0.8 seconds. That's every Western 1252 encoded string, and that's every Unicode string. And if you wanted all the Vietnamese strings, I could change this code page value and pull out all the strings, maybe the Russian strings or fill in the blank investigative need. If they're encoded in a different code page, just pass that in, you're good to go. You'll get just those strings. There's a good example of all the examples that it gives you that are built into the program. If I switch gears here and do another hive, this one's pretty cool. If I do LR and then we do UNC, this is an example from one of my old machines. You could see why that could potentially be nice. What are people interacting with on this machine? There you go. I've got a list of printers. I've got a domain controller access. There's some other thing called Goon. There's a user's UNC down there at the bottom. And it did that extremely quickly. It knows the rules. I don't have to sit there and try and specify something. I don't care what it is. I just want that pattern to be matched. And out comes my data. If I do something like this, oops, I want to do LS. If you do LS, that's not a regular expression. That's just a string. It'll work exactly the same way, and we get the color, the syntax highlighting. So works pretty nice for us. Switch gears again to a different hive. And for anybody that's taken 408, this may or may not look familiar for you, but you can see how it's quick. And it's accurate, and it just gets us down to the information that we want really quickly. How about email addresses? That can always be a pain because you don't know all the different formats and domains and everything else. There's our regular expression for what a legitimate email looks like. There's all your results. 27 strings in 0.1 seconds. So pretty easy to do. Let's do one for WinPath. There you go. Lots of cool stuff. Now this one's neat because it's going to find anything that looks like a Windows path, but we see some of these entries here like this HF, REF, Q, whatever, RKR. That's ROT13 encoded. And so how would you, if you were interested in finding an executable or something, you could go look in user assist or anywhere else that ROT13 is used. But if you were trying to find ROT13 encoded strings that's a path, that might be difficult. So you can kind of back into it. We see these hits. You can copy this string out and then un-ROT13 it, and you'd see whatever the file itself was. There's a couple examples in here. It's Office install and things along those lines. But you get the idea here. We want to basically pass in all of these strings that will then be unpacked into regular expressions based on the list here. So you would just use the name column, and it will do everything else for you. So a couple other interesting ones here is the 3986. But I mean, there's a lot. And then if you wanted to do the sub-filtering, we could do things like the select string and then do file. There you go. So you can further limit things down as opposed to dumping it to a file, which there's switches to dump it to a file, and then going back and grepping again. We could do the same thing here, and you could find all the individual things that were referenced that way. So it's pretty cool. The last thing I want to show you is if I just do a string search for confidential, of course you're going to get the strings out, but notice that there's only 24 hits. So one thing that bstrings does that other tools don't is it deduplicates. So if you find the same string 800 times, I'm not going to show it to you 800 times because why? Then you just go dedupe it anyway. I've just caused you more work. So I dedupe. But if you want the offset, you want to know where the hit was, well then you're not going to dedupe, of course, because they're unique files now. So if you throw the offset switch in there, it's going to find everything. It's still just as fast, but now you see we have 45. And then out here at the end, you can see we've got the offset, and then we have an A for ASCII, whatever your code page is, and then we have the U for Unicode. Okay, so, and there's one that you stored two different ways, and you could go back if you jumped into the file at that offset, you'd see that string, you're good to go. So that's really how bstrings works, and rather than, you can't really like pull a bunch of stuff out. I like to show it live, one, so you can see how fast it is, and two, just how flexible it can be. Some of the other ones that you can do here is you could sort it alphabetically or by length. You can limit it by length. You could limit it by length. I want things that are between 8 and 15 characters. Everything else falls on the floor. And then do entire directories, files. You could export things out. Let's say you have a nice pattern of regular expressions that you always search for. You could put those into a file and then pass the file name into the FR switch, and it'll search for each of those regexes for you. You won't have to do it individually. So last but not least, let's spend our remaining time here. We have a few minutes left, and we'll talk about Timeline Explorer. So it's very simple to use. I'll just go to File and then Open, and then I've got sample output already done, like I mentioned. And here's just a good sampling of a bunch of different types of things. And we could pull these back down to here, wherever you want. Date and time filtering, awesome, right? I can say yesterday, today, last week. Think about you doing an investigation where you have a timeline and you're like, well, we see this a pivot and some weird indicator happened. It was 2 weeks ago. Okay, well, you can go in here and say last week, maybe, or you can. It's going to give you all the unique values. And if I were to go 2011 and then April of 2010, there's my results. I don't have to do anything else with it. If I want to, these are interesting for me for whatever reason. Not this one because it wasn't, we'll do just these because that one wasn't executed. I'll do Control T. You can see here it's tagged. So if I filtered on that one now and just did tagged, now if I wanted to, I could export this out to Excel and I would get just this. Okay. I can also, in here for any of these, conditional formatting, text that contains, we'll do GPG, for example, and we'll just make it red. And you can see that stuff's going to jump out right away. And you can set those up across the board. You can get it as complicated as you want. The filtering and everything else, you can go up here and just do GPG. And then if we edited this filter, you can get as we could do last modified equals whatever you want as well. So you can get it very, very granular as far as these filters go. You could turn them off temporarily. You could see a previous list of all your filters. And these are unique to file type, which makes it nice because you're not muddying the water. You can close and get rid of all the filters by turning that off. Let's look at support for. So this is just a comma separated file. I dynamically parse it and pull it in. So it doesn't matter what it is, it will do that for you, and everything else will work the same way, all the filtering and everything else. Let's look at a timeline. So if I pull in, let's say a super timeline, give it a sec to load up here. The one thing to keep in mind while this is going is this tool is not meant for you to load a 4 gig CSV into, right? It's just, there's just not enough memory to load it in there. It's made for much more segmented and focused timelines, but you can see it's pulled these in. We've got a little over 25,000 lines, and right away you can see we've got like the colors, they look different. Well, if I start scrolling down, you can see that we've got other colors besides this kind of gray. If you've taken a SANS course and you looked at timelines, our color coding is all built into this. So there's our key, right? We've got their file opening, web history, deleted, whatever. There's all this stuff. And so you can just go down the list here and look at all these different things. Now, for people that have taken that and tried to do this in Excel, what's the problem with event logs and things like that? That right here, like this, how am I supposed to make any sense of that? There's forward /n, /t. So one thing that I did is build in a details view, which you can either say click on details or say Control D. And if I do that, I get what actually looks like Event Log Explorer or looking at the Event Log Manager itself. So there's a couple ways that you can now do this. Maybe I go in here and I say 4624. And now I can go in here and either double click a row. Now I want to start going down the list. I can just start browsing and saying next record. Maybe I'm looking for a particular entry. So that's kind of nice, right? I can see my IPs and stuff here. I could pin this to the top and just use the keyboard over here. Lots of different options there. You could do quick filtering on any of this stuff, and it's going to limit it right down. I just type some stuff, and you can see right away we're going to get that, just the matches. So it's really, really quick on how it's filtering and making the data presentation easy for us. Same thing with tagging. This is really where tagging might come into play, where you have 2, 3, 4, 8, who knows how many different things. You can just start tagging these entries that are interesting, and then filter, export out a sub-timeline,